In this video, we're going to demonstrate how to use MATLAB to actually solve a system of linear equations. We've seen this system before, and we were able to write it in matrix form. Our next step, if we're going to use MATLAB to solve it, is to put these matrices in a MATLAB script. We're going to name the script W21, this is week 2, and the first script for that week. If we toggle over to MATLAB, we can make a new file, and we'll save it immediately as W21. And then we can start creating our matrices. So the A matrix has coefficients 1, 2, 3, 2, negative 1, 1, 3, 0, negative 1. 1, 2, 3, 2, negative 1, 1. And last but not least, 3, 0, negative 1. Notice if you put semicolons here, these indicate the change of row or new row. We can run this script and it should show us the A matrix, and in fact that matches exactly what we wanted, which is perfect. The other vector that we want is the B vector, and if we want to make it look like the one that's in the notes, it's just 9, 8, 3 with semicolons, or if you wanted you could do 9, 8, and 3 and then put a transpose at the end, which is that single quote. Either way is fine. There's usually multiple ways to get to where we want to go in MATLAB. So we've created our vector and our matrix, vector B and matrix A. Now, what we'd expect is the process of using Gaussian elimination, which is a mechanical process. You identify the coefficients, you multiply and add rows. Then the idea is that MATLAB presumably has a tool in it that'll actually do that work for us. So what we're going to do is go to the Help menu and see if we can track that down. So if we do F1 to go into the Help menu, we can open the Help browser, and there's a whole pile of stuff we can do, but I think we're going to start with a search. And the search would be search for solving linear equations. Now there's some important ingredients or key things to look for when you're browsing the Help menu here. This looks promising, linear systems of equation in matrix form. However, there's the symbolic math toolbox indicator on this one, and we are not going to be using the symbolic toolbox for this course here, so anything that involves that should be skipped over and looking for ones that might have something a little more promising, like linear algebra sounds promising, or better yet, here we go. Systems of linear equations, mathematics, linear algebra. Let's take a look at that as our starting point. So when you get into these menu items, into these help items, there's a lot of description, especially for something like this, which is a general topic, but what we can take a look at is the idea behind it. So here they're writing things out as AX equals B. That sounds like the kind of thing we're working with. And the way they schedule it out, or we have a solution here, denotes a solution to a matrix equation XA equals B. That's not what we have. We have A times X equals B. X is in the right-hand side. And here's the syntax. If we want the solution vector X, we say that equals A, and then this divide operator B. It's a little sketchy. It's a notation thing. It doesn't actually mean dividing in the traditional sense, but you can see they put the dividing here in quotes. But it gets us a solution for X, and if you read the rest of the documentation, it will tell you that it's using Gaussian elimination and some other algorithms that are appropriate to solving systems of linear equations. So let's give that a try. We're looking for X equals A slash B. So we add that into our script, and we run it again. And we see we actually get 3 values back. X is a column vector. That looks right based on what we saw in our setup. And the numbers are 2, negative 1, and 3. So we're able to do that. We'll record what we found here. A slash B was the way to solve that equation. And we used MATLAB to solve that. And that gave us the X vector as, toggling back, 2, negative 1, 3. With that, the last remaining challenge, we've done all the hard work of solving the equations. The last challenge is to return to the original variables. And remembering the on-paper work, which sets the stage for this, our x vector was actually made of a, b, and c. So if we have a, b, and c as the three elements in that order, our solution would be to the original system that a equals 2, b equals -1, and c equals 3. Perfect. Now, it's never a bad idea to actually check that this solution is correct. Maybe we made a typo, maybe we did some other calculation thing. Is there a nice way to verify that what we found is correct? Well, we can double check our A matrix. It is in fact right. 1, 2, 3, 2, -1, 1. That matches the coefficients we had originally. And what we should get is if we multiply A by x, if we go back to our original equation back here, A times x should give us 9, 8, and 3. So with the values we just found, we better get 9, 8, 3 back when we check the left-hand side, A times x, and there we have it perfectly, 9, 8, and 3 as our right-hand side. That matches the original equation. So with that, we can feel quite confident that when we do A times x and get 9, 8, 3 back, that assuming our A matrix was set up correctly to match the on-paper description, we have the right solution in our x vector, or the right solution for our values of a, b, and c. An important note at this stage is that the sequence of generating some input, computing a result using MATLAB, and then interpreting the result is going to be a common loop. We do this over and over and over again, typically extending the input or the computing side and adding more interpretation at the end. It's all sort of layered on in typical applications, but that's going to be the cycle that's going to help us understand what we're doing and get some interesting results. The interpretation is not something we should skimp over, just getting a number back at the end. We should be able to think about that and reason about whether it's reasonable or whether it makes no sense in the context of the original problem. And that reasoning, that evaluation, will help us figure out whether our input and computational steps are correct or not. The nice thing is what MATLAB did in that script is not doing anything different than what you did by hand. It's just solving that system of equations, this A x equals b system, much faster and with less hassle than you would have had to do if you were solving it by hand. And the advantage just gets even more and more dramatic as we scale to 5 by 5, 10 by 10, the kinds of systems we would never ask students to solve by hand. And that's going to be our platform or our springboard moving forward using linear systems.